All right, let's talk about this a little bit. Now, we want to write the equation. All these are the same. We want to write the equation for the line that's passing through point A, right, parallel to the line through BC. Now, the other kind of problem you might see that's like this is the one where it gives you a picture. And that's okay, too. Then it's going to give you a point on the graph, and you'll have to just find the coordinates of that point. And then it'll give you a line and say, parallel to that line. So that's even easier because you can just make a slope triangle on the graph to find the slope. Here we got to calculate it, but it's no big deal, right? They're all the same, though. What we want to do here is we want to put this into the form. Our goal always is to put this into the form y equals mx plus b. So we just need to know what is m and what is b. Okay, the m is, how am I going to find m? If I want my line to be parallel to line BC, how is my slope going to be related to the slope of BC if they're parallel? Same. Yeah, they're equal. Parallel lines have equal slopes. So the slope of BC then, how would I calculate that? Here's point B and there's point C. How do I calculate slope from 2 points? Good. Subtract the y values. Good. So then on the top I'm going to get what? Now I can subtract the y values, right? So it's going to be like 3 minus negative 9. Okay, so 3 minus negative 9 over negative 9 minus 1. Everybody see that? Okay. So that's going to give me 12 over negative 10, right? Which is, now I get a positive over a negative. So what's that make the sign of the fraction? Negative. I don't want the negative on the bottom, so I'll put the negative out front. And then 10 over 12 reduces to what? Yeah, 6/5. They're both even, so I can divide them both by 2. So there's m. Okay, halfway there, right? Now I got to find b. Now what's our little trick for finding b? Yeah, I can plug in all this stuff, can't I? I know what m is. I know a value of x and y that are on my line, so I can plug in the values for x and y, so the only thing left over is b then, right? So look, what happens when we do that? Let's take a look. So if I plug that stuff in, y is negative 2. M, we said, was negative 6/5. X is 5 plus b. Does everybody see that? How we did that? Yeah. Okay, all we did was we plugged this in there, we plugged that in there, and we plugged that in there, right? Okay, and now we solve for b. All right, well, negative 2 equals, now if I multiply these, I multiply straight across, don't I? But I could also cross-cancel here. If I've got negative 6/5 times 5 over 1, look, those 5s cancel, right? I could multiply straight across and reduce, but why not? Why not just cancel them? So then I get negative 6 times 1 over 1 times 1. Isn't that just negative 6? Okay, any questions on that fraction part? We'll make sure everybody's got that. Because that could be the part where people are having issues. Okay? So negative 2 equals negative 6 plus b. So what do I do to get b by itself? Add 6. And then I get b equals what? 4. Got it. Okay? So it now wants us to leave our answers as simplified fractions. All right? Well, we can do that. Let's put this stuff in here then. How would we enter this? Okay, m, we already said was negative 6/5, so I would just say negative 6/5, like that, plus, or no, hold it, plus b is 4. If b had been negative, I would have put a minus sign there, right? Okay, makes sense? That's it. Questions on that? Okay? All right, so that was one of the problems that was really ugly on the test. If I look at the results, a lot of people missed that one. Here's another one. Not surprisingly. Same kind of thing, only we got to deal with perpendicular now. So this makes it maybe a little bit harder because we got to change the slope of this time. But it's the same idea. Write the equation for the line that passes through A perpendicular to BC. So just like before, we're going to calculate the slope of BC, right? So what do I subtract on the top there? Okay, I'm gonna get that's fine. I can do like 9 minus -2 or -2 minus 9. Doesn't matter as long as I'm consistent. If I'm going to subtract these numbers from these numbers, that's fine, but I have to do it for both the x's and the y's. Or I can do it the other way, but I just have to be consistent. Do the same thing for both x's and y's. So I could say 9 minus -2 over -4 minus -6, right? Everybody see that? Okay. So that's going to give me 11 over 2 is the slope of BC. Now, is that the one that we want? Okay, we want the perpendicular slope. So we want the opposite reciprocal. Yeah, we're going to, so this is positive, ours has to be the opposite, which is negative. Flip the fraction. -2/11 is our slope. Okay. Well, here's x and y. Right? So I'll use the same thing as before. I'm just going to plug in for y equals mx plus b. To solve for b. So y becomes -2. M is -2/11. X is 5 plus b. Right? Okay. So let's solve for b. Now, if I multiply those fractions straight across, what do I get? -10/11. So I get -10 on the top and 11 on the bottom. So what's the one thing I've got to do to get b by itself then? I'm going to add 10/11s to both sides, right? Okay, so I end up then with b equals -2/1 plus 10/11s. Now, how do I add up fractions? Common denominator. Good. So what's my common denominator going to be? 11. Okay, so what do I have to multiply the bottom by over here? 11. Okay. But I got to multiply by the same thing on the top. Because that fraction is just 1, isn't it? There we go. Okay, good. So we end up with -22/11 plus 10/11 equals b. And so finally then, what's -22/11 plus 10/11? -12/11. So there's b, right? There's b, -12/11. We said m was -2/11, and so when we enter that stuff, there's m, x, and it was minus, right? Because wasn't it negative, our b? -12/11. So -2/11 minus 12/11 is our answer. Okay? Make sense? That's it. Okay. All right, moving on. Okay. Yeah, here's another one. Here's another one. Given that angle 3 and angle 8 are supplementary, are the lines A and B parallel? And more importantly, enter the postulates and or theorems that explain why lines A and B are parallel. So if 3 and 8 are supplementary, is that enough information? It is, isn't it? Because if 3 and 8 are supplementary, look what we can do. What's an angle that would, how can I relate 3 and 8 there? Okay, good. 3 and 7 are corresponding angles, so they are congruent, right? And then 7 and 8 are a linear pair. So if 3 and 7 are the same, and 3 and 8 are supplementary, then 7 and 8 must be supplementary also, right? And they're a linear pair. So yeah, that works, doesn't it? Makes them parallel. Okay? So the answer is, are they parallel? Yes. Enter the postulates or theorems that explain why. Well, if we take this route, if we relate 3 to 7 and then 7 to 8, what are the reasons? Well, we've got the 7 and 8 are supplementary by what? Linear pair, postulate, and 3 and 7, if 3 and 7 are congruent, then it makes these lines parallel by what? Corresponding angles converse. So that's one approach we could take. What's another one? Okay, good. So I'm going to go back and I'm going to actually erase this, and we'll try a different one. Yeah, we could do alternate interior, couldn't we? We could do this. We could say 8 and 5 are congruent. Why? Because they're vertical angles. And then if 8 and 5 are the same, and we know that 3 and 8 are supplementary, then 3 and 5 must also be supplementary because they're the same, right? And if 3 and 5 are supplementary, that makes the lines parallel by the consecutive interior angle converse. Because if consecutive interior angles are supplementary, the lines are parallel, right? So that would also work. There's another example of something that would work. We could say vertical angles, or vertical angle postulate, either one. Vertical angles and consecutive interior angle converse. We have to have the converses there because we're showing that the lines are parallel. Right? We're not told they're parallel. We're proving that they're parallel. That's what the converses do. Make sense? There's probably even other ways we could do this one if we wanted to. We could say 3 and 2 by the linear pair postulate, and then 2 and 8 by alternate exterior angle converse. That would work also. Okay, so there's lots of ways to do this one. But the goal is we want to be able to link angles 3 and angles 8. In this case, it's going to take two relationships to link them. They're not directly related this time. Okay? Now, real quick, what if the problem had asked instead, let me do this real quick. So, yeah, it did. Okay, good. So if I clear, there we go. What if this one had been a little bit different? What if it had said 2 and 7? Angle 2 and angle 7 are supplementary. Okay, we could use 2. I've actually changed this one to include, there's a single one that we didn't prove, but that we could use. What's the single relationship that would relate 2 and 7? Remember that one? It's not given to us in the book, but we talked about it, and we sort of talked. We didn't prove it formally, but we informally did. And I'll accept it as a reason. I didn't at first, but I think it's reasonable to do that. So we could do 2. We could say something like 2 and 3 are related by linear pair postulate, and then 3 and 7 by corresponding angle converse. That would work. So you can do this in 2, just like we did the last one. But in this particular case, there's even one single answer we could give. Anybody know what it is? What's the relationship between 2 and 7? Consecutive exteriors. And even though there's not one in the book, there really could be, and maybe should be. We could use the consecutive exterior angle converse, and I would accept that as an answer. I think I can get full credit for that. So if you do that, in this case, that would work. Okay, that'll work. All right, moving on. Now these, these are hard. These are definitely hard, and these were the ones that a lot of people, not very many people got these 100% right. And that's, I don't know if I feel that bad about that because they're pretty hard. I mean, you have to get a high A. Sometimes that's hard to do. I'll quickly go through an example of these. What's the relationship between 1 and 2? If these lines are parallel, and if they're parallel, then they would be congruent, wouldn't they? Because they're alternate exterior angles, and that's what we know. If parallel lines are cut by a transversal, alternate exterior angles are congruent. So I can set them equal to each other, and I'll just real quick zip through this. 2x squared minus 15x minus 48 equals negative 62 plus x squared. Now, just remind me here, I know this is pretty advanced algebra stuff for us to be doing this year. How do we solve an equation like that with x squared, a quadratic equation? What do you think?
You move everything to the left.
Yeah, good. Good, we're going to set it equal to 0. So we're going to add 62 and we're going to subtract x squared from both sides, giving us 0 on the right. On the left side, we'll get 2x squared minus x squared is x squared minus 15x plus 14. Okay? And here's probably the hard part. What do we do now? This is the one that's a little strange. We got to unfoil it. We got to break it apart, right? Because it's too hard. That equation is too hard to find the values of x that are going to make that whole thing equal 0. But it's much easier if I can break it into a product of 2 small pieces. It's easy to ask when that is 0 or when that is 0, right? And we know that a product of 2 things, if I multiply 2 things together and get 0, that means that either the first factor is 0 or the second one is. So if we can factor this thing, then we can get answers easily. But we're going to unfoil it. So I know that I've got x times x is going to give me x squared, but I need to find the magic numbers. Now what do? They multiply to... They multiply, the 2 numbers have to multiply to what up here? 14. Good. So they have to multiply to 14, and they have to add to what? Okay, good. They have to add to negative 15. So what are those numbers? What 2 numbers multiply to positive 14, but add to negative 15? Okay, and positive or negative? Negatives, yeah. So negative 1 and negative 14, right? Negative times negative is positive, but negative 1 plus negative 14 is negative 15, right? And once I've got it factored, how do I get the solutions then? What are the values of x that are going to work? what value of x would make this first factor equal to 0? 1. Okay, so there's one answer. Either x equals 1 or x equals 14, because that's the value that would make this factor 0, right? And then we're just going to check those in the easiest angle to see which one gives us a reasonable answer. Well, that's an easier angle to check right there, isn't it, too? So it says that if the angles appear obtuse, assume they're obtuse. Well, that appears obtuse, so it's got to be bigger than 90 and less than 180, right? So we'll just check. If I put 1 in there, that's easy to do. For x equals 1, I get the measure of angle 2 equals negative 62 plus 1 squared. Well, that's not going to work, is it? That's no good. So I know it's not 1. Let's try, just to make sure, let's try 14. If x equals 14, the measure of angle 2 equals negative 62 plus 14 squared. What's 14 squared?
196.
196. So that's negative 62 plus 196 equals 134. Bingo. That's it, isn't it? That's obtuse. So that's our answer. Okay, so we get x equals 14, right? Okay. The other one you can see, I don't know which one you think is easier. I kind of think these are myself, but I don't know. It's up to you. If I want to solve this system here, real quickly, how could I, let me scoot that over. How could I do that? What are some relationships I know?
1 and 3 are the same.
Okay, 1 and 3 are congruent, so I can set them equal. So that's one thing. So if I set 1 equal to 3, I'm going to get 3x minus 8y minus 27 equals 2x minus 4y plus 8. I want to solve a linear system here, so I want to get these into standard form. So I'm going to push the x's and the y's to one side and the numbers to the other. I don't have to do that, but it just makes it simpler. So if I subtract 2x from both sides, I add 4y, and I'm going to add 27 to push the numbers over there. What do I get for my equation then? Looks like x minus 4y equals 35. So there's one equation, right? The other one I get back is, how about if I do something like 2 and 3 are supplementary? Good, okay. So I could say 6x minus 10y plus 18 plus 2x minus 4y plus 8 equals 180, right? So here we have angle 2 plus angle 3 equals 180, right? If I simplify that, if I combine like terms, 6x and 2x is 8x, good. Negative 10y minus 4y minus 14y. 18 plus 8 plus 26. Okay, and then last step. Yeah, let's push the 26 over here. Subtract 26 from both sides. And so I just get 8x minus 14y equals 154. Okay, so now look what I've got. I've got two equations here. I've got this guy up here, call that equation 1, and I've got that guy there, call that equation 2. And I have to just solve that system. So let's do that. I'm going to rewrite these. So I've got x minus 4y equals 35, right, from here. And 8x minus 14y equals 154. From there, I have to just solve that system. Well, take your pick. How could I solve that system? I could use substitution. Yeah, I could easily solve for x in the top one. Or I could use linear combination. Why not just use substitution, though? That's fine. If I solve this top one for x, I just get x equals 4y plus 35, right? Put a box around that, and I'll substitute. Substitute that into, so all this stuff is going in for x, right? And I get 8 times 4y plus 35 minus 14y equals 154. Now I've just got to solve for y. So if I distribute the 8, 32y plus 280 minus 14y equals 154. So 32y minus 14y is 18y. If I subtract 280, I'm going to get negative 126. Is that right?
Yeah.
And if I divide both sides by 18, then I get y equals what?
Negative 7.
Negative 7. So I got part of it. Now where do I go to get the rest of it? Yeah, right back up to the box. Substitute in and find what x is. Right? So to find x, x would just be 4 times negative 7 plus 35. Well, isn't that just negative 28 plus 35? So x is positive 7. So I got my answers. X is positive 7. Y is negative 7. Okay? I would do those last. That one's not worth that much, and it's kind of the, the icing on the cake. That's the one to get a really high A if you want it. But they take a little while, and they're pretty hard. Okay, what about this? This is much easier. Find the value of x that makes line A parallel to line B. If the measure of angle 1 is this and the measure of angle 6 is that, well, how are 1 and 6 related? How would they need to be related for these two lines to be parallel? If be congruent, sure. So we'd set them equal. So 7x minus 13 equals negative 1x plus 14. What do I do to solve for x? Yeah, just add x to both sides. Add 13. Right? Divide by 8. Now how do they want that? They want it to 2 decimal places, so throw it in the calculator and we got the answer. Okay? This one. Okay, now how do you do these? These are kind of tricky. What I would recommend doing is kind of just filling it in. Maybe sketching out that quick picture and just filling out the puzzle as you go. What do we know here? If x is 48 and we're trying to find 4, well, we can fill in some stuff here. So if that's 48, isn't that 48? And what's this guy up here then? They're a linear pair. They're supplementary. So wouldn't they add to 180? 180 minus 48, so that's 132. Now these two lines are parallel, right? So I know that if that's 48, so's that, right? We got a bunch of stuff here we can fill in. And then these form a right angle, so they're complementary. So what's 5 if that's 48? 42? Don't they have to add to 90? So 90 minus 48 would be 42? Yeah. And let's see, those are vertical angles, so that's 42. Those are vertical angles, so that's 48. See how that works? We're able to fill in a lot of stuff there. And now look at this. We've got this transversal right here, right? And so let's see, what do we know here? Well, 8 and 4 are corresponding angles, aren't they? Everybody see that? Because I've got, here's my transversal. that's cutting through these two parallel lines. So those must be congruent. So angle 4 is 42. And there's probably even a quicker way to get to that. Maybe you found it. I didn't. But so yeah, that's my recommendation. Just kind of fill in the pieces of the puzzle as you go. And eventually, the more information you get, the easier it is to get down here. Okay? Given that 3 and 5 are supplementary, this is another. These are kind of the easier ones. People did, by and large, pretty well on this. If 3 and 5 are supplementary, are lines A and B parallel?
Yeah.
Yeah, they are. How come?
Is there
Not consecutive interior, converse. Good. So we get yes. Whoops. We get yes. We'll try that again. And the reason is just consecutive interior angle converse. Oh, that's it. And I think that's it. We got it. What are we at here? 50? Okay. Does that make sense? Okay. Questions on homework? We got a few minutes here. Questions on the homework stuff from yesterday? Everybody realize homework's up there? Try to get a jump on that. What I'm going to do tomorrow, and I normally, like I said, I normally wouldn't do this. I don't like to be in here without getting some good in-class practice.